Hello everyone. Today's lesson we're going to be talking about performing function operations. So for functions, we can actually perform operations on them. So if we let f and g be any two functions, a new function can be defined by adding, subtracting, multiplying, or dividing our two functions f and g. And so the four operations that we have are typical ones: addition, subtraction, multiplication, and division. And we see that for addition, if we did f plus g of x, that's just going to equal to f of x plus g of x. So for example, in all these examples, our function f is 3x and our function g is x plus 5. So if I was doing f plus g of x, that would equal to f of x, which is 3x, plus g of x, which is x plus 5. So this is f of x, g of x. And I would just add those together. So 3x plus x, I get 4x plus 5. Subtraction is very similar. Instead, you just have f of x minus g of x. So for example, here I have 3x minus x plus 5, which I go ahead and distribute that negative and end up with 2x minus 5. Multiplication, that would be fg of x, which is going to equal to f of x times g of x. So for this example, that would be f of x, which is 3 of x, times x plus 5, which when I distribute that 3x, I get 3x squared plus 15x. And then division, f over g of x is going to equal to f of x divided by g of x. And so here, that would be 3x divided by x plus 5. And something to note here is that the domain of these operations are the domains of f and g combined. So I will look at what's the domain of f, what's the domain of g, and the domain of the whole thing would be those combined. And something to note here is that the domain in the quotient does not include x values where g of x is equal to 0. So for example, in our division example here, this denominator x plus 5 can never equal to 0. So the domain here would be all real numbers except x is equal to negative 5. Because if I plug in negative 5 for x, I would end up with a 0 in the denominator, which we cannot have. So let's go through some examples. First, we're going to look at adding and subtracting two functions. So number one, I have let f of x equal to 3 square root of x and g of x equal to negative 10 square root of x. I'm going to find f plus g of x and f minus g of x. I'm going to state the domain of each, and then I'm going to evaluate those two functions when x is equal to 4. So I'm going to start with just finding f plus g of x and f minus g of x. Well, we learned in our definition above that f plus g of x is equal to f of x plus g of x. Well, f of x is equal to 3 root x, so I get 3 root x plus g of x, which is negative 10 root x. And here I have like radicals. They're both square root of x. So that means I can just add those coefficients. So 3 plus negative 10, I get negative 7 square root of x is equal to my f plus g of x. Okay, now let's go ahead and find f minus g of x. So f minus g of x, that's equal to f of x minus g of x. So I have 3 square root of x minus negative 10 root x, which is the same thing as plus 10 root of x. And so when I add those, I get that f plus, or f minus g of x is equal to 13 square root of x. Okay, and then the next part says to state the domain of each. And so the domain is going to be the same for both because I have the same function f and g. And I'm looking to see, so for both of those functions, what is my domain? Well, I see both of these are square root functions, and we learned with square root functions that we can't have any negative numbers, because if I take the square root of a negative number, that gets me a non-real solution. So that means the domain for both here is going to be x is greater than or equal to 0, because that square root of x has to be positive. And then now I'm going to evaluate both when x is equal to 4. So f plus g of 4 is equal to negative 7 times the square root of 4. Well, the square root of 4 is 2, so I have negative 7 times 2. And so f plus g of 4 is equal to negative 14. Doing the same thing with f minus g. 4 is equal to 13 times the square root of 4, which is equal to 13 times 2. So f minus g of 4 is equal to 26. Okay, let's look at one more example. So here my two functions are f is 3x cubed minus 2x squared plus 5, and g is x cubed minus 3x squared plus 4x minus 2. So first I'm going to find f plus g of x and f minus g of x. So f plus g of x is going to equal to f of x plus g of x. F of x is 3x cubed minus 2x squared plus 5. And g of x is x cubed minus 3x squared plus 4x minus 2. So combining like terms, I have 3x cubed plus x cubed to get 4x cubed. Negative 2x squared minus 3x squared to get negative 5x squared. I only have one x term, so plus 4x. And then 5 minus 2 to get 3. Okay, now we're going to do the same thing, but we're going to do f minus g of x now. So f minus g of x is equal to f of x minus g of x. So I have 3x cubed minus 2x squared plus 5 minus x cubed minus 3x squared plus 4x minus 2. Now I'm subtracting this whole thing, so we learned with polynomials that I need to distribute that negative to each of those terms. So this is going to equal to 3x cubed minus 2x squared plus 5 minus x cubed plus 3x squared minus 4x plus 2. And so combine my like terms, I have 3x cubed minus x cubed to get 2x cubed. Negative 2x squared plus 3x squared to get plus x squared. Minus 4x. And then 5 plus 2 to get 7. Next, I need to determine the domain. The domain for both of these will be the same. And looking at this, I see I have a cubic function on both. And we learned with those that the domain is just going to be all real numbers. There's no restrictions on what x can equal. Now I need to evaluate both of these when x is equal to negative 2. So starting with f plus g of x, f plus g of negative 2. So I have 4 times negative 2 cubed minus 5 times negative 2 squared plus 4 times negative 2 plus 3. This is going to be 4 times negative 2 cubed, I get negative 8. Minus 5 times negative 2 squared, I get 4. Minus 8 plus 3. So I have negative 32 minus 20 minus 8 plus 3. And so f plus g of negative 2 is going to be negative 32 minus 20. I get negative 52. minus 8, I get negative 60, plus 3, I get negative 57. Okay, now we need to do the same thing for f minus g of x. And so when I do f minus g of negative 2, I get 2 times negative 2 cubed plus negative 2 squared minus 4 times negative 2 plus 7. And when you go ahead and make those computations, you should get that f minus g of negative 2 is equal to 3.